Okay, so students, this is the video for us to discuss about the past year paper for paper 6, statistics 1, from the February and March 2016 sitting, right? Okay, so the first question, if you look at it, they tell you that there are 10 values of x, mean value is 86.2, and also this information for the summation of x minus a, and they want you to find the value of summation x and also the constant a. All right, so for first of all, we are going to use the information that given by the question. So which is mean is equals to 86.2. So you know that the x bar mean is equals to 86.2. All right, and therefore try to change it become the formula for mean. So summation x over n equals to 86.2, and therefore you know summation of x divided by 10 is equals to 86.2. And from there you will get summation x equals to 862. All right, so this is our first the answer for the first part. Okay, so for the second part, they want you to get the constant of a. So first of all, you need to know that what is the formula for the mean that link with this summation bracket x minus a. All right, so for your information, there's a formula which links to this one. It is summation of x minus a divided by n plus a. And since you already know that the mean value is 86.2 given in the question, okay, so 86.2 equals to summation of a, which is x minus a, which is 362 divided by 10, and you get a plus a here. And from there, you will get a, which is equals to 50. The value of a is equals to 50. All right, so these are the information that we are going to use, all right, in solving this question. All right, so let's proceed to question number 2. Right, so for question number 2, if you look at the question here, there's a flower shop with 5 yellow roses, 3 red roses, 2 white roses, and Martin chooses 3 roses at random. So in my opinion, okay, I would suggest that you look at this keyword, they choose. All right, so the word choose give you an idea that you should use a combination method to get the answer later. Okay, so draw out a probability distribution table for the number of white roses Martin choose. So they are focusing on the number of white roses. All right. Okay. So maybe if for your better understanding, I will let x equals to the number of white roses. Okay. So you are having 3 roses in total. All right. So the possible number of white roses will be can be x equals to 0. All right, that means there's no white roses. So if let's say there's no white roses, when you want to choose the other color roses, you can treat this whole group as other color and the white roses as the second group. So we are having 8. So when you're having 0 white roses, that means you want to choose 3 roses from other color multiply with 0 white roses. So the 2 here denote the 2 white roses. All right. Okay, so the 8 here means 5 plus 3 equals to 8. Then you want to choose 3 roses. So divided by, to get the probability, you need to divide it by the combination without any restriction. So combination without any restriction, in this case, it will be 10C3. Total, you're having 3 roses and you want to choose 3 roses in total. All right, so if you try to press the calculator and get the answer, you get 7 over 15. Okay, so the same thing applies for the other value. So I might get 1 roses, 1 white rose, okay, in my selection. So for this case, I'm having 2 roses from other color, and also 1 rose from the white color. So 2C1 divided by the total without restriction is still the same, which is 10C3. And from here, you get 7 over 15. Okay, you can press the calculator and give you this answer. And another option is, another possible answer will be, you can get 2 roses. Okay, so if you want to have 2 roses, means that other color roses you have only 1. So 8, choose 1. Okay, multiply with 2. choose 2 and divided by 10 C 3. So for this case, you are having 1 over 15. Alright, so is it possible for you to get x equals to 3? That means the number of white roses equals to 3. That will be impossible because you can see that in our question here, we have only a total of 2 white roses. So it is impossible for us to get x equals to 3, which means that our calculation has been completed. Right, so after you completed all the calculation, then you draw the probability distribution table to show all the result that you have here. All right, so the first row will be the x, and the second row will be the p, the probability. So when x equals to 0, you are having 7 over 15. So when x equals to 1, the probability is also 7 over 15. And after that, when x equals to 2, the probability that you get is 1 over 15. So this is the probability distribution table that you should show. Alright, so if you want to double check your final answer and see whether is it correct or not, then you try to total up all the probability together and see whether you get the value equals to 1 or not. If you didn't get the total equals to 1, that means something wrong in your calculation. Alright, so for this example, you can see that the total for these 3 probability is equals to 1. And therefore, I believe that this is the correct answer. Alright. Okay, so this is what you have for question number 2. Alright, then now we will proceed to question number 3. Okay, so for question number 3, I'm having a 8-sided die, a fair 8-sided die, and then with the faces marked 1, 2, 3, 4, 5, 6, 7, 8. Alright, so they are talking about the score. So the score when the die thrown is the number of the face the die lands on. So they give you two definition, for the events. So before that, you should know that the die is thrown twice. Alright, so you have the definition for event R and also the definition for event S. Okay, then from the question, they want you to find out the probability for R, S, and also R and S are independent or not. Okay, so for this question, there are a few ways for us to solve it. And because of, I see the keyword, the die is thrown twice, I think it will be good if let's say I can use the possibility space diagram to show my result. Alright, so to get the possibility space diagram, I need to draw a table. Okay, so with 1, 2, 3, okay, so this is for die number 1, or maybe when you throw the dice for the first time, this is the result. And when you throw the dice for second time, then the result that you'll get is also from 1 until 8. Okay, so I think we need to adjust it a bit. Alright, so from here you can see that there are total 8 multiplied with 8, which is equal to 64 outcomes that we will get from this possibility space diagram. So 64 outcomes here. Alright, and now we are going to try to label all the events defined in the question. So now we look at event R. So what is event R? Event R means one of the scores is exactly 3 greater than the other score. So exactly 3 greater than the other score. Alright, so by so maybe by using some common sense, if I look at the first cell here, alright, 1 and 1. Okay, so for this one, 1 minus 1, you get a 0. So the difference, for one score with another one is not exactly 3. Alright, so the possible answer will be here. Okay, maybe I can use the other color of the highlighter so that you can see clearly. Okay, so maybe this one. Okay, because for this outcome, you are having 4 minus 1, which is equals to 3. And it is exactly 3 greater than the other score. So one of the score is exactly 3 greater than the other score. So what is other possible result for event R? So another one will be here. Okay, I think I need to say. Okay, so to use the blue color highlighter, this one is one of my score. And then the second one is here, 5 minus 2, you get 3. 6 minus 3, you get 3. 7 minus 4, you get a 3. Then 8 minus 5, you get 3. Okay, and besides, you can double check with other outcomes here. So if you realize that this cell is actually 4 minus 1, the difference is also equals to 3. Okay, and then 5 minus 2 is equals to 3, 6 minus 3, 7 minus 4, and also 8 minus 5. So all these are actually the outcomes for the event R. All right. Okay, so maybe for me, what I would prefer to do is like maybe I make a P here. So this one is actually event R. All right. Okay. So to calculate the probability of event R, it will be very straightforward. Calculate how many highlighted cells are there, and you divided it by the total, which is the sample space. Okay. So if you try to calculate it, there are 10 highlighted cells divided by the total outcome, which is 64. 8 plus, 8 multiplied with 8, you get a 64. And to simplify, you get 5 over 32. So this is the probability for event R. Okay, so now we can try to find out the outcome of event S. Alright, so event S means the product of the score that is more than 19. Alright, so from here you should know that all the lower scores here, when they multiply with each other, product means multiply with each other, right? So when you multiply them with each other, right, you won't get any value that is more than 19. So the first result for the product which is more than 19 will appear here, where you take 7 multiplied with 3, you get 19. Correct or not? Then this one also, 8 multiplied with 3, you get 24. So you have to check one by one. Right? 4 multiplied with 4, you get a 16, which is not part of the event S. Okay, so 5 multiplied with 4, you get 20. 6 multiplied with 4, 7 multiplied with 4, 8 multiplied with 4. Okay, so for the next row or next column, you will see that 5 multiplied with 4, you get 20. Then the rest of the column. All right, and after that, for the next column itself, we will be 6 multiplied with 4 and the rest of the column. Okay, then for 7 multiplied with 3, you get 21 and also the rest of the column. And after that, for the last column, it will be all this. Okay, start from 8 multiplied with 3, you get a 24 and the rest of the cell. All right, so for the red color part, you can actually try to write a key where this is actually the event S. Okay, all right. So how to calculate the probability for event S? All right, so to get the probability for event S, again, you need to do the counting on how many highlighted cells with pink color. Okay, so if you calculate the total cells that highlighted in pink, you have 28 cells divided by the total, which is 64, and therefore you get 7 over 16. Okay, so in my opinion, every time when we have two dices, or maybe when you throw a die for twice, generally the outcome can be shown very well by using the possibility space diagram. All right, so for me, this is a good method. Okay, if we are having any two dices or any question with two dices, or maybe when we have one dice and one coin to show all the outcome, a possibility space diagram is a good method to show. Okay, right, so let us continue to part number 3. So for part number 3, they want you to determine whether the event R and S are independent and justify your answer. Okay, so to justify, first I need to find out the probability for R intersect with S. So how can I get the probability for R intersect with S? So you need to count again. There are how many cells that you have both both highlighted color in one cell. All right. So as an example, you can see this one. This is the first one that it consists of two highlighted color. So this is the second cell, the third cell, and also the fourth cell. So from here you can see that the number of cells that consists of both highlighted color will be 4, then divided by 64, and therefore you get 1 over 16. So this is the first step. You need to find out the probability for R intersect S. And secondly, you need to find out the answer for R multiplied with the probability of S. So since you already get the answer just now in the first part and the second part, so you just multiply them straight away and you will get the 35 over 512. Okay, so to decide whether R and S are independent events or not, you have to compare these two values. All right, so you have to compare, and you will realize that these two values are actually not the same. So you can write out the reason. Since R intersect S is not equal to probability of R multiplied with the probability of S, and therefore R and S are not independent. Alright, so this is how you solve the question number 3. Okay, so we are going to discuss question number 4 now. So for this question, they give you a cumulative frequency table with all the upper class boundary. And for the first question, they ask you to state how many journey time were between 25 to 45 minutes. All right, so between 25 to 45 minutes means the value, okay, between 25 to 45. Okay, and since this is the cumulative frequency table, right, so to get the original frequency, okay, for the class from 25 to 45, you have to take the cumulative frequency minus the previous cumulative frequency, which is 50 minus the 18. All right, and you get the 32 as the frequency that is between the class for 25 to 45 minutes. Right? Okay, so for second part, they want you to draw a histogram on graph paper to represent the data. All right, so before I draw the graph paper, I need to have the width of the class, boundary, and also each frequency for the class boundary. Therefore, it will be easier if, let's say, I show the answer by using a table. Okay, so first of all, I want to know, okay, what are the class boundaries that I have? Okay, so from this question itself, you already know that one of the classes from this is actually from 25 to 45. Right, so I will have a class from 25 to 45. You may try to guess what will be the class represented for this column. So it will be from 10 to 25. All right, and then for the previous one, for this one, it should be 0 to 10. And because of the value is 0, and therefore I'm not going to include it in our table here. All right, okay, so how about the next table? So for the next table, for the next column, it will be from 45. All right, so it will be from 45 to 60. And after that, the last class will be from 60 to 80. Alright, so this is my class boundary, and therefore I actually no need to do any adjustment anymore, because you can see that if you double check the value for the upper class interval, compare it with the lower class interval for the next one, so you can see that they are actually having the same value. Therefore, there's no adjustment needed, alright, to make it become the same value. So all these are class boundaries already. Okay, and after that, I'm going to get the frequency from the cumulative frequency table. So for just now, right, you already know that the cumulative frequency table, if you want to get back the frequency value, you have to take the later cumulative frequency minus the previous one. So as an example for part number 1, okay, the frequency for the class 25 to 45, it is 32. So you can put a 32 here. You did the same thing for the other classes. So For the first class, you are taking 18 minus the 10, which is 18. All right, so for this class, 45 to 60, you should take 59 minus the 50, where you will get a 9. And for the last class here, to get the frequency, you take 63 minus the 59. And from here, you should be able to get a 4. All right, so this is actually my frequency. So you have to calculate the frequency out by yourself one by one from the cumulative frequency table. All right, so the next one. To sketch the histogram, what we need is the width. All right, if you double check with the width here, okay, so width means upper class boundary, 25, minus the lower class boundary, which is the 10. All right, so what will be the width for the first class? It will be 15. Okay, the width for the second class will be 20, 45 minus 25. The width for the third class will be 15 as well, and the width for the last class will be 20. All right. Okay, so from here, you can see very clearly that the width, okay, of every classes are different. Okay, therefore, to sketch a histogram, you need frequency density. Okay, so how can I get the frequency density? So just a reminder. All right, so the frequency density formula is equals to frequency divided by width. All right, so from here, after you check the values of width, you realize that they are not the same from classes to classes, right? Therefore, when you want to sketch histogram, you need the frequency density. So you take the frequency divided by the width. All right, so for the first class, you will get 1.2 as your frequency density. The second class, you will get 1.6. All right, then the third one, you should get 0.6. And also the last one, you will get 0.2. All right, so once you are ready with all the information already, then you can start drawing the histogram. All right, so to draw the histogram on the table, first of all, you should look at the frequency density lah. All right, the y-axis will be the frequency density. This is the y-axis, and the x-axis will be your class boundaries. Okay, all right, so for the frequency density, the highest value is 1.6. So maybe for us, we can include it for the scale like this. Okay. All right, so let me try it out here. Okay, so maybe I can make my graph like this. Okay, so for the y-axis, it will be the frequency density. Okay, and then for every point here, every 10 boxes here, I will put it at 0.5, and this is 1.0, 1.5, and 2. Okay, and for my x-axis, I will make it as 10. No, sorry. Because of I need to have 80, right, for my x-axis. So this one will be 20, 40, 60, and 80. So don't forget to label your x-axis as well. Okay, so the x-axis will be actually the journey time. In minutes. All right, and the y-axis will be the frequency density for sure. All right, so now for the first class from 10 to 25, the frequency density is 1.2. So 10 to 25, okay, so 10 is here. 25 will be the center between the 20 to 30, so it will be roughly here in the center. All right, so the height will be at 1.2. Okay, and then from 25 to 45, Okay, the height will be 1.6. So the 1.6 will be somewhere here. Okay, so maybe I draw it better. Okay, so 45 is here. So 1.6 is here. Okay, and from 45 to 60, the height is 0.6. So 0.6 will be here. All right, and also the last one. So the last one will be 60 to 80. The height will be 0.2. So it will look something like this. Okay, so this is our frequency, our histogram lah, with the unequal width. All right. Okay, so in this solution, I think you need to show all the value for the frequency density in the solution. Okay. All right. So this is what you have for our histogram here. Okay. Then for the next question, for part number 3. So for part number 3, they want you to calculate the estimate of the mean. Okay, so they want you to calculate the mean value, okay, for the journey time. All right, so to calculate the mean value, generally you need the x lah. So I will create another column with the x, okay, which is the midpoint of the class boundary or class interval. Okay, so for the class boundary here, to get the midpoint, you will take 10 plus 25 and divide it by 2. So 10 plus 25 divided by 2, the midpoint is 5. Okay, so the same thing happened for the rest of the class. So you're having, sorry, I make a mistake here. So 10 plus 25 divided by 2, it should be 17.5. All right, and after that, the rest of the row will be 35. The rest of the midpoint, 52.5 and also 70. All right, so for part number 3, when they want us to calculate the probability, want us to calculate the estimate of the mean. Okay, so the formula is summation of fx divided by the summation of f, right? Okay, right. So now, what is the summation of fx? You take the frequency multiply with the midpoint. So frequency is 18 for the first class, multiply with the midpoint, which is 17.5. All right, then you do the same thing for the rest of the row. Frequency multiply with x, frequency multiply with x, and also frequency multiply with x divided by the total frequency. So the total frequency will be 63. Okay, so when you press calculator, try to get the value, you get 2187.5 and divide it by 63. Your final answer for the mean will be 34.7, correct to the 3 significant figure. All right. Okay, so in your solution, you have to show somewhere in your steps with all the midpoint value. Right, you can show it in a table form if you want, or you can show it in your steps if you want. All right, so this is the solution for question number 4. Okay, so for question number 5, all right, 35% of the people take a holiday, okay, in holiday abroad. All right, and then 65% take a holiday in their own country. And after that, for those who going abroad, 80% go to seaside, 15% go camping, 5% take a city break, and in their own country, 120% go seaside, and the rest are divided equally for camping and also the city break. All right, so if you look at question number part 1 and part 2, generally they are asking for probability. Okay, so for this one, because I can see that there are 2 stages here. The first stage is talking about they go holiday either abroad or in their own country. And after that, in the second stage, they are talking about the holiday activities. All right, so to calculate the probability for this case, I will suggest to draw a tree diagram before you can find the answer. Okay, answer the question that they want you to do to answer. So now for the first stage, I'm having going abroad. All right, or you can use some other letter. Okay, then this one maybe I write as own country. Okay, so 35 of people taking holiday abroad. So this is 0.35 and this one is 0.65. Okay, and after that, they're having three types of activity. Okay, so the first type is seaside. After that, camping and also city break. Okay, then the same thing happen for seaside, for those who have holiday in their own country also. So camping and also city break. Okay, so from here I need to fill in all the probability as well. Okay, so the first one go to seaside is 80%, then camping 15%, and the rest will be city break, which is 5%. All right, then for own country one, go to seaside is 20%, so 0.2, and after that it divide equally. Right, so the remaining will be 80%, right? 20% go to seaside, so 80% go for the rest. So for 80%, they divide equally, which means each of the activity here we are having 40% each. So which is 0.4 and also 0.4. So from here you can see that this is a complete tree diagram, okay, for us to do the calculation later. All right, so let us have a look for the first part of the question. Okay, so a person is chosen at random. So given that, please highlight the word given that. So this keyword tells you that this is actually a question about conditional probability. Okay, so the person chosen goes camping, find the probability that the person goes abroad. Okay, so since you know that it is a conditional probability, right, given that, which event happened first? Goes camping happened first. You know that it is known that the person go camping first, and we want to find the probability that he goes abroad. All right, so this is a symbol for the conditional probability that we have. Okay, so what is the formula for conditional probability? So it will be abroad intersect with camping divided by go camping. Okay, all right, so now let's start to put in all the possible values from the tree diagram. Okay, so for the first one, they are talking about abroad. Okay, abroad intersect with camping. So if you look at the tree diagram, you follow the pathway that includes abroad and also the camping one, which is this color. Okay, so you can see that to get the probability, you multiply them together, which is 0.35 multiplied with 0.15. Okay, and divided by camping. So for divided by camping one, generally, right, you have to include all the possible probability for camping. But for any tree diagram, as I told you before, right, if you want to calculate any probability, you cannot start halfway. You cannot start it halfway here. Then you only consider the 0.15. This is not allowed. You have to start from the beginning, okay, of the tree diagram. All right, so to get a camping, the first pathway you are having is this one, okay, which is 0.35 multiplied with 0.15. And is there any other possible outcome or not about camping one? So for own country, you are having camping as the activity also, which is 0.65 multiplied with 0.4. Okay, right, so these are the two possible outcomes that we have the activity as camping. So you have to include all these pathway, the probability for this pathway, and calculate it inside. So if you complete everything, you should get 0.0525 divided by 0.3125, and end up you should have the answer, which is 0.168, or you will get 21 over 125. Okay, so this is what you have for question number 5, part 1. All right, okay, then if you look at part number 2, there's a group of n people is chosen randomly. Okay, and then the probability of all people in the group taking a holiday in their own country is less than 0.02. Find the smallest possible value of n. Okay, so for this particular question, right, before we start, you need to try and identify what is it about. Okay, I don't know whether you can see the pattern or not, but generally you have n people And out of the n people, right, all these people, okay, having holiday in their own country. So when you see this kind of structure, right, okay, you're having a group of people, n is like your total trial, okay, all the people means that the number of x, the value of x, and the own country means that something happened to these people, all right? So this one I will save as the event happened, okay? So what is the probability for this event happen? Okay, taking holiday in the own country is 0.65. So from all the structure here, generally, right, you can write out as something like this. X is actually the number of people, okay, having holiday in own country, okay? And then from here, you can actually identify that X is binomial distributed with n. And what is the probability that these people having holiday in own country? It is 0.65. And they actually want you to find the n, right? So to find out the n, you actually need the information from the question. So you can see that this is the information less than 0.002. Okay, all people in the group taking a holiday in their own country. So means that if you write it out, it will become something like this. When x, the number of people taking holiday is equals to n. All means n, all right? And the probability is less than 0.002. Okay, all right. So what is the formula for binomial distribution that we are having x equals to n? So you have NCR. So in this case, it will be NCN, all right? Then 0.65 power n and 0.35 power 0 smaller than 0.002. Okay, all right. And after that, because you know that this NCN, you can try to press the calculator and see lah. So no matter you get 2C2, 3C3, 4C4, everything is equals to 1. Then any value that is power 0, you will get also a 1. Okay, so and now for this inequality, what do you get is you get 0.65 power n. It is smaller than 0.002. Okay, so to get the value of n, you need to take log both sides. Okay, and after that, if you want to um, bring the log over, log 0.65 over, okay, you need to change the sign. Okay, why do I need to change the sign? It is because of this value itself, it is a negative value. So we want to move a negative value to the other side, you need to change the sign of the inequality. Okay, and if you continue from here, n will be greater than 14.4, and therefore n must be a integer, right? Because they are talking about the number of people. Okay, so n should be equals to 50. Okay, so let's talk about discuss about the question number 6. Okay, so Hannah choose 5 singers from 15 applicants. So I'm having 5 singers here from 15 applicants to appear in the concert. She lists 5 singers in the order. So I think you should highlight the word order, which means that the sequence is important in this case, okay, in which they will perform. So when you see the word order, it means that the sequence is very important. So generally, when we want to do the calculation for all the number of ways, it will be either permutation or we will involve all the factorial. Okay, right. So first of all, how many different lists can Hannah make? So you want to choose 15 applicants. Oh, sorry, you want to choose five singer from 15 applicants, and the order is important. And you want to arrange them, it means so it will be either 15 P5 or you can write it as 15 C5 multiply with 5 factorial. So for this one, it actually means that you choose 5 singers first and after that you arrange the sequence that they perform. Also can. So you realize that the answer will be the same for this case, which will be 360 and 360. Okay, so this is a straightforward question. All right. Okay, then now continue to the second part. Okay, so of the 15 applicants, 10 are female and also 5 are male. All right, so let us have a look. What is the restriction now? Find the number of leads in which the first performer is male, second is female, the third is male, fourth is female, and the fifth is male. Okay, so if let's say they want to have sequence like this is male, okay, then this is female, this is male, female, and male. Okay, so now you're having 5 male in total and then 10 female in total. Okay, all right, so now maybe we consider the very first place lah, right? The first one who performed. Okay, so for the first one, they want it to be a male. So how many males can I have a selection? Okay, so for here, for this position itself, for this sequence, right, the first to perform, I want a male. So generally, I'm having 5 male. Okay, so there are 5 different males, 5 possibilities, 5 different results or outcomes that I can have for this position. Okay, so after you put, that means you put one male here already, therefore you left 4 males only. Okay, all right, then now you go to the second one. So the second to perform is a female. All right, you're having 10 female now, which means that for this second one who want to perform, you will have 10 different outcomes. Okay, so that means you put one female here, you left 9 female. Okay, then for the third one also the same, you want a female again, you want a male again. So to get a male now, you currently have 4 male left only. Therefore, there are only 4 different outcomes that you might have here as male. So you put one male here and end up you have left 3 males, 3 male. Okay, then the fourth one is female. Okay, so you have 9, left 8. The last one, repeat the same thing again, and you have a 3. Because you left 3 males only here, right? So multiply all the numbers here together and you will get the different ways, okay, the number of lists that we have. Okay, so for this one, you should get 5,400. All right, so this is what we have for the second part. Okay, all right, then now we go to the third one. Okay, so for the third one, they have some extra rules again. All right, so Hannah's friend Amy would like the group of 5 performers to include more males than female. So now this is another restriction. They want to have more males than females. Okay, so the order now is no longer relevant. So when they say the order is no longer relevant, right? Okay, the how to say, the method that we are using now will be focused more on combination. Okay, instead of permutation, so we'll focus more on combination. All right, so they want to have more males than female. Okay, then question number 3, find the number of different selection. So you see the keyword selection also. This further tells you that we want to use combination to answer the question now. Okay, of 5 performers with more males than female. Okay, so when you want to have more males than female, for 5 performers, right, you can have 3 male and 2 female. You can have also 4 male with 1 female, and also 5 male with 0 female. So all these are the cases that we have more males than females. Okay, all right, so to get 3 male and 2 females, right, now because of selection, we want to choose only. The sequence of performance is not important anymore, so we are using combination. All right, so you're having 3, you want to have 3, so you have 5 males in total and you want to choose 3 of them only. Okay, and then you are having 10 female and you want to choose only 2 of them, so it will be 5C2 and 10C2. You need to multiply them. Why is it a multiply? Because this multiplier makes a complete case. All right, Because if you only have 5C3, that means your group only have male. You don't have any female yet. All right, so you have to multiply them so that you have both male and female in the group. Okay, so 5C3 multiplied with 10C2. Okay, you'll get an answer. I don't know what is the answer. You can calculate it by yourself. And then 4 male and 1 female, it will be 5C4 multiplied with 10C1. Okay, and after that, 5C5 multiplied with 10C0. Okay, so that means 5 male, you want to choose 5 male out, and then out of the 10 females, you want to choose 0 of them. Okay, so if you have all the results already for the cases, all the answer for the different cases, then you can total them together. Okay, so you add them together for part A, for the first case, second case, and the third case, and eventually the value that you get should be 501. Okay, so this is what we have for our part number 3. Okay, so let us continue to part number 4. Further, they add on more restrictions. Okay, so 2 of the applicants are Mr. and Mrs. Blake. All right, and find the number of different selections include. So again, selections again, now you can see it gives you a hint that we are doing the combination here that includes Mr. and Mrs. Blake and also fulfill Army's requirement. Okay, so this one seems like a little bit more tricky. Okay, so maybe you can draw it out if you want. So let's say I have a male now. Okay, and this is Mr. Blake. All right, and I want 3 males in the group, right? And 2 females in the group also. And I actually have 1 female also. This is Mrs. Blake. Blake, okay? All right, so now if you look at this one, to make sure that the requirement is still fulfilled, right? So I still group them into female and male. So from here, you can see that I actually need how many male? I have 2 males left. Okay, the empty space for 2 males and 1 empty space for female. Okay, and for the number of males and females remaining, right? Exclude Mr. Blake, I have only 4 males now to be chosen. Then exclude Mrs. Blake, then you have only 9 females. Okay, all right, so now let us start with the first case, which is still the 3 male and also 2 female, which is what I draw here. Okay, so 3 male and 2 female. So if I want to have 3 male in the group, right? So now I only need to choose the 2 empty space for male only. Okay, so which means I'm having 4C2. Okay, multiply with what? How many female I need to choose? I have only 1 empty space for the female. Therefore, it will be 9C1. And I multiply them together to get one of the answer. So this is a case 1 answer. Okay, how about if we proceed to 4 male and 1 female? Okay, so if you want to go for 4 male and 1 female, then if I try to draw it out again, 1, 2, 3, 4, 5. Okay, now I want to have 4 male and then 1 female. And this female is already occupied by Mrs. Blake. All right, then 1 occupied by Mr. Blake. Okay, sorry, maybe I can move it down a bit and draw in a better way. Okay, so now 4 male and 1 female. So 1 female, 4 male. And then the female, the space is already occupied by Mrs. Blake. And then Mr. Blake also occupied 1 space, okay, for the male side. All right, then now, which means now you need to choose 3 male only. You don't need to choose the female anymore, right? Because there's no more empty space for the female. So for the second case here, out of the 4 male, you want to choose out 3 of them. And you get the answer for case number 2. Okay, so if they want to have 5 male, is it possible to have 5 male and 0 female? Then if let's say you want to have 5 male and 0 female, it means that it doesn't fulfill that both applicants, Mr. and Mrs. Blake, are in the group. All right, so you cannot consider the case which is 5 male and 0 female. All right, okay, so for these two cases, after you get the answer, you total them, plus them together. All right, and therefore the answer for this case will be 58. Okay, so this is what we have for question number 6. All right, okay, so let's proceed to question number 7. Okay, so for question number 7, if you read the question, generally you can see this keyword. They are talking about time taken by a garage to fit a tow bar, and this important keyword is normally distribution. Is normal distribution or normally distributed. The mean we don't know, and the standard deviation is 0.35. Okay, so it is found that 95% of times taken are longer than 0.9 hours, and they want you to calculate the value of m. Okay, so first of all, what you should do is like, you know that it is normally distributed, therefore you can write out the symbol here. The mean is unknown, which is the m, and then the standard deviation is 0.35, and then you square it. Okay, so this is a symbol that we have lah. Right, so when they want you to find the m, right, they give you the extra information, which is 95% for the time longer than 0.9 hour. So if you want to write out the symbol correctly, it will be the probability that the time taken is longer than 0.9, and the probability is 0.95. Okay, so this is the information that I get it from this sentence here. All right, so the next step will be you need to do the standardization. So how to do the standardization? You take the value of x minus the mean divided by standard deviation, and you let it equals to 0.95. Okay, so from here, I know that if I draw a normal graph, my graph will look something like this. Okay, so this is a 0.95. 0.95 is a large area, should be more than 5, 0.5. And then this sign here means that you should shade the area on the right hand side. So which means from all this, I will know that my value of this z should be on the left hand side or below 0. That means it should be a negative value. Okay, and this whole area is 0.95. Okay, so this whole area is 0.95. Okay, and therefore what I want to do now is I want to find out this value. So this value is actually 0.9 minus m divided by 0.35. Okay, so the greater sign here means that I shaded the area on the right hand side of this line. Okay, and it should be a large area, which is 0.95. Okay, so now I have to use the normal distribution table to find out the value, okay, for this z. All right, so how can I find it out? Okay, so you can try to find out from the very bottom part of the normal distribution table provided in our formula booklet. Okay, so 0.95 is a special value, which is it will appear in this smaller normal distribution table. So if you look at this 0.95, right, the value of z is actually 1.645, sorry. Okay, so what you can do is like, you know that this value 0.9 minus m divided by 0.35, the value should be 1.645. But because of the graph, from the graph, you know that any value on the left hand side of 0, it should be a negative value. On the right hand side of 0, it should be a positive value, right? So for this one, it will not be a positive 1.645, it will be a negative 1.645. Okay, so this is how we get the value negative 1.645 from the table. Okay, then after that, you can continue from here. So to get the value of m, what you need to do is like just move everything to the other side. Okay, and eventually you should get the m is equals to 0.9 plus 1.645 multiplied with 0.35. And the final answer for m, it should be equals to 1.47575 47575, sorry, wait, 47575. And of course, I want to change it become three significant figure, so it will become 1.68. Okay, so this is the answer for M that we have. Okay, then now let's continue to question number 2. Okay, so for question number 2, on one day, there are 4 cars. Okay, have a tow bar fitted. Find the probability that none of them takes more than 2 hours to fit. Okay, so again, more than 2 hours to fit. All right, so again, I want you to have a look for the structure here. Originally, I'm having 4 cars, a total number of car, and then none of the cars. So they're talking about the number of cars, right? What happened to the car? Take more than 2 hours to fit. So when you see this kind of structure, it means they are talking about the uh, binomial distribution. Okay, so the 4 cars here, it will be something like your n. Then this is the number of x, none of them. So that means x equals to 0 or y equals to 0. And then more than 2 hours to fit. So this is the probability that you need to put, okay, for a single event to happen. So you need to put it inside the symbol for binomial distribution. All right, so maybe now I can write out y. I don't want to use x anymore, right? Because just now I already used x. So y, maybe I can write as the number of cars. Okay, because now we are talking about the number of cars that takes more than 2 hours to fit. Okay, and y is binomial distributed with 4. And now I need to put in the p. But what is the p here? The p here, we need to find out the time more than 2 hours. Okay, so first of all, you need to find out the probability x greater than 2. So the x greater than 2 come from first part now, which is the normal distributed question. Okay, so for first part, x, we are talking about the time taken by a garage, right? So now to get more than 2 hours to fit, you need to find the probability here. Okay, so it is a normal distribution, so you have to change it become z first. So z is greater than 2 minus the mean. So what is the mean that you get? You get 1.48 just now divided by standard deviation. So the standard deviation will be 0.35. Okay, so just a reminder, when you write out the answer, you can write out 1.48 here, but when you press the calculator to get the final answer, please make sure that you get the long answer, long value here. Okay, so if you try to put in the long value for me, I will get z greater than 1.698. Okay, so how to find the probability for 1.498? Sorry, it is not 698, it should be 498. Okay, so to get the probability for 1.498, you look at 1.4, 1.49. So what's the value that you get? 1.49, this is the value that you get, and then 8. 8 means this one. Okay, so which means you need to take 0.9319 plus 0.0011. Okay, you have to add them together because this is add, alright? Okay, then if you add them together, what is the answer that you get it from here? You'll get 0.9330. Okay, so for come back to our solution here, because they are asking for greater than, right? All the answer that provided in our normal table is smaller than. So to get the greater than, you have to take 1 minus the smaller than answer. So this is a smaller than answer, which is 0.9330. So if you continue from here and up, you'll get 0.067. Okay, so is this 0.067 the final answer that we want to find? It is not yet. Okay, it is just halfway. Right, so now let's continue further. Okay, so this one is 0.09330. Okay, so now the 0.067 I can put it here as the P for binomial distribution. All right, okay. Then they're asking for none of them. So that means none of the car, which means the probability that y equals to 0 takes longer than 2 hours to fix them. So when you're having y equals to 0, and now the y is binomial distributed, right? So you have to use the binomial formula, which is 4C0, 0.067 power 0, and then 1 minus p. So what is your 1 minus p here? It is 0.933 lah. So 0.933 power 4. Okay, so if you press the calculator and correct it to 3 significant figure, it will be 0.758. Alright, so this is what we have for the second part. Okay, then now let's have a look for the third part. Okay, so for the third part, they are saying that the time in hours taken by another garage to fit a tow bar onto a car have another distribution, which is mu as sigma square, where the mu is equals to 3 sigma. Okay, then now they want you to calculate the probability that it takes more than 0.6 mils hour to fit a tow bar onto a randomly chosen car at this garage. Okay, so now maybe for the third part, I will write all the answer here. Okay, make it as another x, all right? So x is normally distributed also, where you are having the mean and sigma square. So since they already tell you the mean is 3 sigma, so you can put it here straight away as 3 sigma. So you're having 3 sigma as the mean and sigma square as the variance. All right, so now they want to find the probability that it takes more than, so more than is more than 0.6 mean hours, okay, to fit a tow bar onto a randomly chosen car at this garage. Okay, so this is what they want us to find. Okay, so first of all, you need to find out you need to standardize it, right? But before we standardize it, I will want to change the mu become in terms of sigma. So you take 0.6 multiply with 3 and you get 1.8 sigma. Okay, so from here only you try to standardize it. 1.8 sigma minus the mean, which is 3, divided by standard deviation, which is the sigma. Okay, so z greater than, so 1.8 minus the 3, what do you get? You get negative 1.2 sigma divided by sigma, and they actually want to find out the probability that z greater than negative 1.2. So this probability z greater than negative 1.2, it is equivalent as z smaller than 1.2. Okay, so you can straight away find out the table from z greater than, z smaller than 1.2. So again, you look at 1.2 straight away. Look at this sign. This is 1.2 and the value is 0.8849. So which is very straightforward. The final answer for this one will be 0.8849. Okay, or you can change it become 3 significant figure, which is 0.885. Right, so this is how we actually answer the question number 7.